Part 4 of this video series is about the quadratic formula, and you're probably very familiar with this formula. You've probably seen it before. You might even have it memorized, and you've probably used it to actually solve quadratic equations. But have you ever wondered where it actually came from? Do you know? It turns out that you get this formula by solving the general quadratic equation. So the quadratic formula is the solution to this equation. And we call this the general quadratic equation because it represents every single possible quadratic equation that you could ever write. So if you solve this equation for x, then you should get this. And that's what we're going to do in this video. So let's get started. I'm going to start with this equation. It is given to us. It's the general quadratic equation, and it's important to note at this point that a is not equal to 0. You see, if a was equal to 0, we wouldn't have this term, and then we wouldn't have a quadratic at all. In fact, we would have a linear equation. It would just be bx plus c, and to solve that, we can just use our properties of equality, and we don't need a quadratic formula. And we'll see why this is an important note as we move forward through our derivation. So the first thing we're going to do here is use the subtraction property of equality and just move that c to the other side. And next, I just divide both sides of this equation by a, and that's where our little note up here is important. You see, if a was actually equal to 0, we couldn't do this because dividing by 0 is undefined. But here we use the division property of equality with our non-zero a, really to get a coefficient of 1 on our leading term there. So, and this is a little tricky right here. Now I've used the addition property of equality to add this expression to both sides of the equation. And why did I choose to add that expression? I could have added anything to both sides of this equation. I could have added 7 to both sides or 100 or whatever. But really, you'll notice that this particular constant term on the left-hand side completes this square. What did I do? I took half of this thing, half of b over a, that's b over 2a, and then I squared it in order to make the left-hand side a perfect square. This is now a perfect square on the left-hand side. And because I added it to the left side, I also have to add it to the right. And so now I can factor my perfect square. So I added this particular term in order to complete the square on the left-hand side. And then when I factor the left-hand side, I get the entire left-hand side is now being squared, and which means eventually I should be able to take the square root of both sides of this equation in order to get rid of that squaring and get my x out. And I'm going to continue that on the next slide, but we got to do a little work on our right-hand side before we're ready to take the square root. So the first thing I did was found a common denominator. And now I can actually do that fraction subtraction on the right-hand side. And you're starting to see the formation of some familiar pieces of the quadratic formula, I'm sure. And so I think I'm ready now to take the square root of both sides of this thing. So when I square root the left-hand side, I just get rid of that squaring. And when I square root the right-hand side, notice I've got my plus or minus because I have to consider both the positive and negative square roots of when I take the square root of both sides. And the bottom is a perfect square, 4a squared. When I take the square root of that, I just get 2a. And so I can take the square root of the top and then the square root of the bottom separately, and that's helpful. Now, it's pretty simple. I just use the subtraction property of equality. I subtract this b over 2a to the other side, And because there's already a common denominator, I can just do the whole subtraction, and there's my quadratic formula. And the the value of the quadratic formula is that we can take a problem where we're expected to solve for x, let's say. And if we have a quadratic formula and we want to solve for x, we got to use all sorts of crazy strategies to do that sometimes. But what the quadratic formula does for us is it allows us to take that solve for x problem and turn it into basically a computation problem. So let's just do an example real quick. This is the same problem from earlier in the lesson. And we're going to solve this using the quadratic formula. But we got to note a couple important things. Remember where the quadratic formula comes from. It says if ax squared plus bx plus c equals 0, and a is not equal to 0, then we can just plug in the a, the b, and the c over here in order to get our x values that make this equation true. So that's what I got to do first. I'm going to use the subtraction property of equality to make my equation equal to 0 and make it look like the general quadratic. And then I can go picking out the leading coefficient, the coefficient of this term, and the constant term, and just identify those here, and then substitute them in to this formula. And then I've got to very carefully do some computation. I'm going to begin by figuring out all this stuff underneath the square root. And maybe you already did that, but if you square 6 and then add 16, you get 52. And so that is what's under the square root. And it's worth noting that that part of the quadratic formula has a special name. It's called the discriminant. And we can learn some information just by looking at that. So what you can tell right now, our discriminant is 52. And so first of all, it's positive. So we know that we can take the square root of positive numbers. So there actually is a solution. If we got a negative number in the discriminant, like negative 52, for example, then that would indicate that there is no solution, or at least no real solution to this quadratic. Also, if the discriminant equals 0, well, the square root of 0 is 0, and then if we added or subtracted 0 from a number, it wouldn't change that number. So if the discriminant is equal to 0, our original quadratic that we were given is a perfect square. And then finally, if our discriminant is a square number like 9 or 16 or 25, then chances are we probably could have factored that quadratic. We're not going to end up with an irrational solution. So there might have been a way to factor that quadratic if the discriminant is a square number. So just some information about how the quadratic formula is related to various types of quadratic equations. But let's continue with our solution. So we could just leave it here, but there's some simplification that we can do. When I see that 52, I know I can't take the square root of that, but I can factor it in a very specific way so that I have an actual square number that I factored out. And the reason I want to factor a square number out of 52, like 4, is because then I could divide up my square root into the product of two square roots, and I can actually evaluate this one. And when I do that, I get, the square root of 4 is 2. And now I can actually do some division to simplify this thing a little bit. And now you're starting to see that our solution is the same as it was when we solved this problem by completing the square. So I'm just going to leave this final task. I've given you this quadratic equation here at the bottom, and you should try to solve it in 4 different ways. First of all, by factoring and using the zero product property, by completing the square. Notice there's a hint here for you. And then use the quadratic formula, and you should get the same solution every single time with all these different methods. And then finally, see if you can graph this thing to find the solution. And we'll check in about that in our next session.